Good morning to all. A very good morning to all the participants. I, Amol Wani, Assistant Professor of ENTC Department, welcomes you all, the participants, to the last day, last session of this AICT sponsored short-term training program on digitally controlled power converters for industrial and renewable applications, Phase 3 under AQI scheme from 14 to 19 December 2020, organized by Department of Electronics and Telecommunication Engineering and Electrical Engineering of SSBT's College of Engineering and Technology, Bamburi, Jalgaon. Before starting this session, here are few instructions from the coordinator to the participants regarding test and certificate. Dear participants, there will be the evaluation test MCQ based after this session, whose link will be shared in the chat box. Please note this, the link will be going to share on the chat box, which will be activated and remain active till 3 p.m. today. This test is mandatory. The certificates will be issued to participants fulfilling the attendance criteria of 80% and minimum 60% marks in the test. After this session, there will be a valedictory function in which the interested participants are requested to give their valuable feedback. For this, they may share their names on our WhatsApp or contact to Mr. Nilesh Mahajan, sir. The participants fulfilling the attendance and test criteria will be issued the certificate to their registered email with us. Hence, all the participants are requested not to leave the group till they receive certificate. Further, all instructions will be shared on the WhatsApp group. Thank you. So now we'll continue the program. It will be a great pleasure for me to introduce our today's speaker, Dr. Ashish Panchal, sir. Dr. Panchal, sir, I welcome you.
Thank you.
In short, I will just give the introduction of our today's speaker, Dr. Ashish Kiranbhai Panchal, Professor, Electrical Engineering Department at SVNIT, Surat, Gujarat. Sir has completed PhD in solar photovoltaics from IIT Mumbai and MTech in Energy Systems Engineering also from IIT Bombay. Having rich academic experience of 23 years, he received many awards and honors. Award for excellence in PhD thesis work, Best Paper Presentation Award at 18th International Solar Photovoltaic Energy Conference, QIP scholarship during MTech studies at IIT Bombay, gold medal for securing highest marks in electrical power system subject. Sir has many sponsored research projects to his credit and received grants from many projects from Internal Nano Electronics Users Program, IIT Bombay, MHRD, Government of India, also from T-Cube, SVNIT Surat, IST, and many more. Dr. Panchal has published number of research papers in various reputed international journals and conferences. He is active reviewer of various reputed national and international journals such as Elsewhere, Sage Publications, Taylor and Francis Publications, AIP Publications, Springer Publications, and many more. He is also West Coast reviewer on solar photovoltaics at IIT. Sir is a recognized PhD guide with 4 students completed PhD under his guidance and 23 plus students completed their MTech. Along with this, he has many outgoing activities with prestigious positions such as stakeholder for solar power plant and other solar activities at Surat Municipal Corporation Surat, co-chairman for Energy and Renewable Energy Committee at HGCCI Surat, projects with IIT Bombay through INUP International Nanoelectronics Users Program and National Center for Photovoltaic Research in Education Program. His area of interest includes renewable energy technologies, silicon-based solar cells technology, micro and nano material characterization techniques, advanced electrical power systems with renewable energy sources. I welcome you, sir. We are lucky that you are here with us in this FDP program. Once again, I welcome you and hand over the dais for the session.
Thank you. Am I audible?
Yes, sir.
PPT is also visible.
Yes, sir. The PPT is also visible.
Okay. Giving nice introduction about me. With this, I'm going to start about my session. So the theme is that lecture power electronics. Okay. Nowadays, power electronics in but one thing is very vulnerable. Okay. So they depends where, like, depends on the side. Okay, the output power, that wind output power depends on wind direction, wind speed, location, etc. Okay. When you want to employ the power, you must know the characteristic, what is the characteristic of the renewable source. Okay, which is mostly not covered in power electronics lectures. Okay, so I thought that people have considered lot of power electronics for your this STT. So I thought that why not to consider solar photovoltaics and how does it and why you need power renewable sources model, because many times you want to design the system, you need to model. Okay, so how to model it, how to control it. Okay, and then because so I will try to touch upon one of the design domestic solar photovoltaic system design. Okay. Okay, so in nutshell, the presentation silicon atom to system. Okay, so how silicon atom is useful for system drive, right? And majority of the content is selected from your first speaker, Professor Chetan Singh Solanki. He has written many books on solar photovoltaics. So one of the book is a very good book in solar photovoltaic actions. Okay, so that book covers atom to system, right? So I will try to cater a few things from here. Okay, now as we know that silicon today, even in market, 89% market capture is. Okay, I will take example of silicon first, right? So now you can, since your department is electronics and you are related with electrical, electronics, telecommunication. Okay, so this silicon is your silicon, these engineers, right? So let us say silicon. So silicon has two types of doping. One is P. Uh, and and okay, so where do metals, okay, or these contents, right, like boron and P-type and N-type silicon, what will happen? A junction is formed, and that junction is very popular junction, that is PN junction. PN junction is bread and butter. Okay, without it can't work. So like means P-type and N-type silicon is right. And when the Venn diagram, okay, what says there is excess. Okay, so here from the background of electronics physics, diagram is known. Oh, the Venn diagram of a PN junction, right? So what will happen? The energy there on the low. Oh, okay, there is a band in between, and that diagram is known as energy. And particularly 1.12 conduction band and so minimum energy in the conduction difference is band gap status 1 to electron volts for right. Of course, there are other semiconducting materials as well in semiconducting electronics, but we will mainly focus on silicon as I gave you the reason why silicon. Okay, and of experiments on this silicon diode. Okay, PN junction diode. But now let us today expose this PN junction silicon diode the light. What will happen? Okay, let us expose this diode to the silicon. Now, NDF is N is of holes from P type and from N type separation and built-in voltage that is indicating this band. Built-in voltage that is the reason for that 0.6 or 0.5 or whatever the voltage you take. Okay, so that is inherent voltage developed. That is known as built-in voltage, right? Now, what will happen that is this silicon to sunlight? Then what will happen when it is not exposed to sunlight? All the and very calmly. Okay, not us. They are the holes. Okay, so under dark or under nothing, very calm condition, that okay, and they sit calmly, right? And conduction band is no charge. Okay, because all electrons they are hiding them here, right? Now what will that whenever sun falling on this junction, okay, whenever falling on can be some is there some and that excites the electron and then okay because okay, an electron they jump okay because they have very high energy they jump from leaving their seat and they are now moving in the conduction band. Okay, and the free motion of electron, that is nothing but the current. Okay, let me tell you illustrate this example with very simple our daily life. One other hand and mother going with that child on the road. Okay, now suddenly one balloon wala or some chocolate wala, no, he is trying to tempting that child. Okay, the child give her mother's hand and then right. So why that child? Because that chocolate wala hai, that external party tempted that child. So that so now child is not and child that move free there. Okay. Towards the conduction band. Okay. Now from light and they jump over here. Okay, the electron cannot sit on this higher energy level. Why? Because this energy level for immediately electron will move towards the lower energy. It's like the water that is flowing terrace or terrace to level. Yes.
Hello. Sorry to interrupt you, sir. Your voice is somewhat breaking.
I don't know, but now is it clear?
Yes, sir. Now it is clear.
Okay.
Okay, thank you, sir.
Yeah. So as the water flows higher to lower energy level. Okay. And what will happen that over here? Okay. Most of the leaves the empty space, they are holes. Okay. So for holes, they are very high. So hole in this direction. This is high energy level for holes and this is the low energy level for holes. Okay. So what will happen due to this light, electrons, they jump and they pile up on the end side. Semi holes, they will pile. Right. Am I audible now clearly?
Yes, sir. Yes, yes.
Okay.
Yes,
okay.
yes.
So now, because of this, what happened that because of light, there is a charge separation. What do you mean by charge separation? Electrons, they gather here on N type and on P type. Okay. Now see, P type have many charge and N type is negatively charged. Okay. Now these device is ready to deliver power. Why? Because P is positively charged and the voltage. Remember, in electrostatic, whenever there is a charge separation, it is related with it is related with the. So similarly, because of light, the electrons are gathered here on N type and the holes are gathered on P type. So voltage is developed. Now, if you connect a load like bulb load or resistive load, and what electrons path, external path from this external wire to load. Okay. Their path through external electrical load like this. Okay. Now see, there are other charges also, holes. So hole move in clockwise direction, anti-clockwise direction. Okay. As a result, what happens? Net current will flow from electrical load. As it is thus is hitting the resistance, thus it is charging the battery, and so many applications. This is photo. Okay, let me again tell you, because of they are getting, they over here and immediately they inside, and holes they pile up on the P side. Okay, see, there are many holes on P type and many electrons on N type. So what will happen? P type is positive charge and N type is negative charge. It means that is law, and that voltage, when P is positive charge, the P is negative. What is that condition? That condition is forward condition. So here, due to light, forward voltage is generated. Forward voltage is generated. Okay, and hence electron they move in this direction. And as you know, the opposite to the, so net current this the current coming out from the positive terminal of the PN junction. Is that right? And see, if you have visited any electrical machines, okay, see there also is that current is coming out armature from photovoltaics coming type junction. Okay, and that is why effect is known as photovoltaic effect. What do you mean by photo? Photo is light. What is voltage? Voltage is generated because of light or because of sunlight. The forward effect of photovoltaic effect. Okay, so that how silicon is producing light. Okay, or how does a solar cell or how does a PV module that work? Okay, there are what when the diode, okay, but okay, it's a combination of two processes simultaneously. One that is that is very popular equation in electronics, that junction is forward bias. Okay, current by exponential fusion of current. Fusion of current as you increase the voltage, right? And what is this minus I is coming out because of photo, because of light. Now, very easy to write the equation. What is the equation about what is the solar cell? Minus the light generated current. Okay, so diode current, as you know, I0 that is the light generated current. Okay, so this light and you find the photovoltaic. Okay, now I understood how does silicon diode generate electrical power, right? Now with that, let me show you what does the structure look like. Okay, let me tell you, let me warn you here, do not take your electronic or electrical laboratory diode and society will not generate power for you. Then don't blame me, okay, because that diode will not work to generate power. Okay, because the construction use electro laboratory and solar cell. Yeah, okay, principle of operation is same, but the construction is different. How does construction of solar cell diode look like? Okay, so there is a p-type silicon wafer. Okay, this wafer is 300 to 50 micron thick, and over there is a very thin 5 micron or 1 micron n-type layer diffused. Okay. So that makes p base and n emitter. Okay. So this is making PN. Now, what silicon wafer is very polished, and it seems like a mirror. Okay, even you can see your face in this. So what will happen when reflect the light? Okay, and whenever the light is reflected, so generated current will be less. Okay, it means that whatever the light falling on the on this solar, okay, it absorb. It should not select it. Absorb. Only a higher current will be produced. Is known as anti-reflection coating. What is the function of this anti-reflection coating? It does not allow the light to be reflected. Okay, it will try to send the light. Okay, into junction. So anti-reflection coating and other texture. So not okay. So one major function should not be reflected. It has to be so one. Then when charges are separated, electrical contacts, front contact as well as back electrical contacts to collect the charges. Then only those charges can move towards the outer electrical circuit. Okay. So you need front contact and you need back contact. Okay. Front contact is of finger and bus bar. You can see. Can you see my hand? These are the fingers. Okay, and this is the bus bar. This type of arrangement is shown on the front side. Okay, the back type contact, back contact is completely filled. Okay, complete back type. Whereas you have bus bar type of on front side. Why this is required? Because suppose if the front is fully light will and metal that will reflect the light. Okay, so that is not our purpose. So what is that you need to leave space between fingers. Okay, and all the electrons they will be collected by these fingers and then they will be circulated towards this bus bar. Okay, so here titanium, palladium and silver contact, and back is fully covered with aluminum, right? So this is the complete structure of solar cell. Okay, and it's a large junction. Okay, you can 2 meters square, 3 meters square. So diode like this. Okay, so which is totally different than your diode which is used in electronic, right? This is the real structure where you have 200 micron thick, 250, 300 micron thick base, then micrometer thick emitter, shared front and rear contact, full real contact. Okay, so this is the real of the solar cell structure, right? And it's large area structure. And now you have to simultaneously remember this equation as well. What is that equation? I will QT KT minus 1 minus I. As you know, am I audible and my slides are visible? Is that right?
Yes, sir. Yes. Yes, sir.
Okay.
Sir. Visible. Slides are visible. You are audible.
Okay. Okay. So now you can see that will zero no current. Okay, in diode. But when you increase the voltage, exponentially charges diffuse along their respective junction. Okay, so there is increment in linear increase in voltage. Okay, you are exponential. Okay, diode characteristic. When you reverse the connection, okay, then what will happen? Very small, which is known as ideally that is to minus 5 minus so almost 0. So this is characteristic like that. Forward direction doesn't have very well known reason for you. Okay, that is this current is known as diffuser current, right? Now, so these diode current, if you see the resistance, okay, if you reverse the connection, then current will increase. If you current will increase voltage. So the resistance is linked by this region. Okay, now where the slide, what will happen? Lot of charges they are coming out of the by direction. Okay, so pull the direction, and what will happen? How much you have to pull, that is corresponding. Okay, because it is I0. So you have to pull that. Z is nothing but the characteristic of a source. Okay. Nothing but the characteristic. Now see the falling in the quadrant. What do you mean by third quadrant? Voltage is positive and current. First quadrant is positive, current is negative. When is positive, current is positive, that device absorbs power. Okay. But voltage negative, like this generates this source giving power to. Okay, that is why the characteristic is falling. Okay, so this red characteristic is solar cell characteristic, right? But engineers have over here. Okay, because very easy for me to work with the first one. Right? So actual characteristic, that is I in quarter. This purpose I will draw. So you will see any paper or any book or any material on solar photovoltaic characteristic is drawn in the first quadrant, but it is not real characteristic. It is the real characteristic that is drawn in the third quadrant. So how to take that solar cell and that solar cell to sunlight? I expose that solar cell to sunlight. Let us assume that this phone is a solar cell, solar panel. First voltage is and two, that voltage is open circuit voltage. Okay, no current because you have not connected load, so no, right? Voltage open. Now I will remove voltage and I will connect an ammeter with this PN junction. I will connect a ammeter with PN junction, and what will happen that will read some current. Okay, ammeter current. Okay, it obtain points. One is zero voltage means short circuit current, one is zero current means open circuit. These two extreme points are okay. Now how to midpoint? Okay, let us connect 1 ohm resistance. Will have because of some current that will be less than IC. Now 1 ohm is this kind of 5 ohm is connected, and what will happen? Output voltage will develop. Okay, then 10 ohm. Output voltage will develop, current drops. Now output current will drop and voltage will develop. Okay, now let us say 100 ohm. What happened? Now current will try to drop very steeply. Okay, and there is a little increasing voltage. Okay. Little volt current has is okay, and much increase. Okay, now let us connect 1000. So what will happen? 1000 ohm current is almost zero and will connect 10,000 ohm. So this circuit is as good as open circuit. Okay, no current will flow and the voltage is open circuit voltage. Okay, so this way I have measured the IV characteristic, right? Now, these two short circuit current and open circuit voltage, they are very important, right? Because they are extreme points. Current as increase and current is okay, but what will happen? There is not much increase in voltage, but what will happen? Above this type curve. Okay. It means that for this multiplication, there is a particular voltage and current for which power of the it is maximum. Okay. That power is known as system power. Okay. And I am always interested at voltage panel. Okay. Remember that I will not run my panel without this maximum power point. Okay. And also you need to remember if light changes outside, if the temperature changes, this maximum power point is going to be different. Means the say it is go to another value. Heavily influence society, intensity as well as temperature. So the third point BI for minimum, or I need to control the current of this autonomy. Okay, then only system. Otherwise, I will not use this system because there is I VOC ISC power. Okay, ideally speaking, we require VOC into ISC power, but in reality, what you get VM and IM. Okay, in reality, you get VM and IM, and in ideality, you expect VOC. Is that real power is always less than expected power. Okay, real power is always less than expected power, and that power ratio is okay. Or IM product divided by VOC IS is this dotted and the rate area between the areas and rate that will decide a fill factor. Okay, so this fill factor is also an important parameter to design the solar cell, to fabricate the solar cell. Okay, now your solar cell is very important because in transformer, what is input? Electrical input. So output is electrical, input is also electrical. Okay, but here the output is electrical, DC output power, and input is light. Okay, so light input is hardly 18% converted into electricity, right? Because of basics, material limitations. Okay, it converts lit, right? Of course, it is not also ideal. So I okay, and the short circuit point is for maximum power, voltage for maximum power. Okay, and as you know that short circuit current that depends on light. Okay, nothing but how many are striking per meter cube per second. The solar means that G is the current, right? Now see if G so because of that, what will that change? Okay, so throughout this is really challenge that at the morning 7 the current is different, at 10 current is different, at 12 and at 5 current is different. Yeah. Now this is okay. See, so the characteristic is that actually it seems that open circuit voltage increases with temperature, but it's not like that. Okay, so VOC cyclic temperature. Okay, so as the temperature increases, open circuit voltage reduces. Okay, so as the temperature voltage reduces, so what is the meaning that if I take the panel in Jhargaon, some 15 voltage, but if the panel is made right now in Jammu, the temperature is very low. Okay, volt, maybe 16 volt, right? So temperature is affect circuit. Okay, so light intensity that is affected by current is affected by the light intensity, and open circuit voltage that is affected by the temperature. Open circuit voltage that is affected by the temperature, right? The our PV curve maximum power, and you remember that that okay, and remember that this where our load AC loads. Okay, of course we have DC loads as well, but majority of the loads they are AC load as well. Why I am saying this, or why I am saying this line? Power electronics converters are needed. Okay, so here there is a role of electrical electronics. Without that, this system is of no use. But here, okay, so then is all. Why it will deliver less is output ISC. Okay, so look at here efficiency. What is we can be placed as we in FF energy. Okay, like incident energy. And now efficiency is very important term because because light as well as temperature. Okay, see, ISC is influenced by light, VOC is influenced by temperature. Okay, now suppose suppose efficiency is poor, then what will happen? For the same light, the output power will be low, and you require large. But suppose efficiency is higher, output for this, it means that factor for land requirement as well as for the structure to the that is also okay. Efficiency is very important term, right? So cell maximum open, very high socket current and very high fill factor. Okay, numer. Okay, otherwise what happen if you go for buying the panel, then the same light and for the same how the okay, so if you a power plant in Mumbai, okay, you see what is the cost. Okay, so efficiency is very important parameter. Okay. So when you go to buy to buy, you ask what is the efficiency? Is 20%, 18%, it is 10%, 6%, throw it. Because now see, one solar cell, as you know, okay, so okay, but happen in the area of the cell. Okay, but if you increase the voltage, then number of cells, right? 1, 2, 3, 4. 0.5. First, for battery recharging for and as we know that battery is 12 volt. Okay, so what they have done, they have right, since overhead voltage. When you connect that load, that voltage will be 14 or 14 volt battery PV panel that will the 12 volt. See any module, you see the number of cells, they are multiple of 36 or 36 cells, because you need to charge the battery, and the system is because this is DC system. Okay, so if you count the number of cells, that is they are see these are solar panels, right? If you now 12 12 9 9, so there are different types of available from different manufacturers, right? And the beauty is that if you want 3 watt panels available in the market, if you want 300 watt panels in the market, okay, that is generating power boiler turbine system. You can't tell 300 watt boiler system, but that's 100 power for you, right? But here the mobile, if you try to run your watch, if you try to or if you try to run fan or AC, these can supply very. This is called it's very flexible. It can adjust to load, right? You have to connect number of solar panels. Okay, solar panels in series and parallel to meet your demand, load demand. Okay. Now, as I told you, the light, the is light intensity. Okay. Now you all agree that in the if 730, no, very pink color light is there. Okay. Why? Because the majority of the light is power is very okay. That in watt meter square. Okay. You take 1 meter square area of the panel and how much light is falling and how much of that light is generating, that is 1000 watt. Okay. So light intensity is in the body is very pink. And 11. Okay. As the day intensity increases, and at 12 noon, the 12 noon sun overhead and the solar panel, right? It means during that time, that intensity is 1000 watt per meter square. Okay. Now, as the day progresses further towards that's towards the set, in the intensity that will be 1200 and 5. It means that throughout the day, it is changing. Why it is changing? Because outside the temperature is changing. Every time the characteristic and 40, 40, 80 and 100, that is 12 noon. That power will system, right? So, and for engineers, there are two engines. One, they operating in all electrical engineers have one power DC and the other all the time need to control the design. These are the challenges are overcome by these engineers that will be in the following. So I do say that throughout the changing, okay, and all the time you need to maximum power. Now see, as the light density, when temperature changes, active voltage will reduce. Or the temperature has good effect on the solar panel. Okay, it will reduce. As you know, as the light intensity reduces, the reduces power from the panel is going to reduce. That maximum temperature. Okay, simultaneously all the time you need to extract from the solar panel. Okay, these are the two challenges, right? Now if you look at if you have looked up the characteristic, okay, you see what are the applications, right? In India, even if in government, okay, that government has noted down that 18,452 villages in India, they are not yet electrified. Okay, 18,452. Why? Because they are on a mountain or hilly area, or they are on island. Okay, where it responds. What is option? Like, okay, this is also the beauty. The coal power can, okay, but sunlight is everywhere evenly available. Okay, and make use of that sunlight and use the rural electrification. Okay, so one panel of 40 is sufficient to charge the battery, and during night time that battery power is evacuated from the battery and charging their and TV and some rural electric yeah, right. Now see, in earlier application, when you hear is generating during daytime, this that the power generation is during daytime. So you store component that is battery. Okay, battery that is for it. So you count what is one problem to come, that is right. There are large panels. Okay. Many panels so okay, any converted into AC and directly here then such a large system is generating power, you don't need to store the power, feed it into the, and then grid will so here you don't need battery connection to the battery. So one piece where you need battery, and the other is known as grid connected system where you don't need battery. Okay, types of major load. Now the thing is that, or the challenge is that throughout, because of the change in sunlight intensity, because to change every 5 minutes, every 10 minutes, the condition is going to change. Okay, when the condition is going to change, the maximum power point is going. So how that is like connect? Suppose I have a battery connect to the PV panel. Okay, so what will happen that when connected to the battery may take, just say, because I don't have control. Battery will, that how PV power cannot force the battery. So what will happen that 5 hour the battery will take a week together to charge the for. Okay, now the use of electric vehicle comes up. Okay, so now you think engine within a few minutes, within 5 minutes or within a 2 minutes. Okay. But now if replaced, this engine driven vehicles are replaced with electrical vehicles, then when you go to charging station वाला बोलेगा कि आप aren't, you wait for it. So in that case, you need very fast charging. So what you have to do, higher and higher power, pump higher and higher power within a limited time in the battery. Okay, and whenever you want to pump the very high power into the battery, okay, this circuit will be capable. Okay, what does it mean? You need to have faith, which will derive this task. What will be that task? That whatever the energy is generated, dump into the battery very fast. Dump into the battery very fast. Now the condition outside is changed. Then collect the maximum power, dump into the battery. Extract the maximum power, dump maximum. Where an electric circuit will provide the battery. 6, now it will be charged within 1 day. It means that when employ and interface circuit, charging becomes fast. Charging it means you try to regulate, you try to control your system with an electrical circuit. Okay, and that electrical circuit, okay, DC-DC converter. Have used this laboratory. Okay, so converter switches, they are very important. Okay, and I hope some practicals also you have seen Professor Mulla, and you have also listened some of the converters lectures by session. Important. And you are aware that by giving an example, that if you connect and if you connect the battery through converter, what will happen? Okay, so you really appreciate that required and what was required. Okay, battery is also DC. Right? So by what are you doing actually? And this, okay, so what are actually you from and you try to match the resistance from the battery side. Okay, so when source is low, at that time the power transfer is maximum. Okay, it means that If battery, then that or maybe over here, either A point or at B point. Okay. It means you are not extracting maximum power. PV means 50-watt power wasted in the battery. Okay. But if I enter this, then PV is generating 100 batteries, so power. Okay. Instead of 50-watt, is expected because the rate of charge is in, and this along with this maximum power known as MPPT, maximum power point tracking. Okay, maximum power point tracking. So let me tell you here, no PC without this phase N. So whenever these employ this, okay, and so PV system where there is PV. Okay, these are now you can see throughout the day. 200,000 at 12 noon. Okay, then again the characteristic is maximum power, that is at 7 the power is here, at 10 power is here, at 11 power 30 here, 12 delivering power. Power is changing. So this is the variation in output power as well as temperature. So of course, we need to know that panel converter and load that has to know that what is, has the condition changed. If the condition is changed, then the P voltage has to be adjusted to extract maximum power. Now suppose after some time then also change, so you adjust the duty ratio of the converter, power is generated, and that is done without losing. Okay, so what you need to know that system is so you and microcontroller, that microcontroller will sense the change in voltage and current. Whenever the voltage and current is sensed, that there is a change, control will to everything. This is mathematical operation. Mathematical operation is done in microcontroller. There is a change in condition. What do you mean by condition? Temperature or radiation? Then microcontroller will try to plot the characteristic, and it will find dp by dv equals 0. What do you mean by dp is maximum power? And microcontroller will tell the converter that now you operate at this voltage. Okay. Control that and that voltage. Okay. Now sometime that 800 change. So again, I to draw the find the power. Now find maximum power. Right, and this algorithm is developed itself. Okay, and this so what is that? Suppose it is in such a way that point is over here. Okay, now voltage is V1. Now I will increase the voltage by changing the duty ratio, and let's say voltage is V2 and power is P2. Okay, now I will take P2 minus P1 over V2 minus P1 over V2 minus is ID to the correct voltage and happens. The voltage V2 similarly measure voltage power. V2 minus P1 over V2 minus V1 means wrong. Then you will try to reduce the and if you try to okay. We will try to come the ratio. Okay, and then only this PV panel that is transmitting maximum power to the load.
Yeah. Okay. Chalu.
मिला नहीं चल
Okay, so yes, so this algorithm, PowerPoint algorithm, and the point. Okay, now suppose in that way, PVD, microcontroller, converter, and load that will supply the maximum power from PV to the load. Okay, so this power, this algorithm is known as maximum power point algorithm. Perturb and observe. Perturbing voltage, observe the perturb, observe perturb the voltage, sign, observe the sign of power. Okay, that is so these. There's another perturb which I will see. I will the instantaneous conductance. Okay. Will get the okay. So this algorithm is incremental conductance algorithm. Okay. So that will also have a maximum power over. Okay. This that is not advantage. Control and it is very advantageous, very beneficial. Okay, so we need to see that people that charge of this charge control, the control is also known as battery is empty. From PV panel. Okay. Batteries. Then what will PV panel? This converter, where this controller will disconnect the PV to the load. Now during night time, anymore, so disconnect the PV panel. Happen that PV panel is a load on the battery and battery the PV panel. So these are advantages, right? So you need to PV panel during time. And during night time, the DC load is on. Is either connected to the charge controller, and that is known as smart charge controller. Okay. Now say load. Other converter, which is AC to AC converter, your AC load. Okay. Sometimes in rainy season, what will happen that the sunlight is not sufficient to drive the load. Okay. So power from the power that is coming from grid. Okay. So this is known as in industry. You may have this or so in industry also diesel that is very famous in industry, because diesel generation is very costly compared to me. Okay, so what is done in industry? Time is generated from PV and power plant diesel side. Okay, and whenever PV is reducing, the power supplemented by this. Okay, so another challenge for this electric, how to design a converter which will balance this DG, okay, and supply the power. So with this, I will conclude this first session. So right, how silicon is behaving, how panel or solar cell, then how we put change with light and temperature, and then how to make the module to for over here, that about the CAC converters, because they are already covered in the previous classes. Okay, but I gave you that whenever you interface any converter, it is doing nothing but matching. Okay, when maximum transferred. Okay, so this code, this is the converter and its design and its control, this class. Okay, I hope that it is covered in the other classes, but whatever I that is also new to you. Okay, because many a times these things are not covered, that how the system looks like and how does with different environmental conditions. Okay. So if you have any, so if organizer allows me, other or maybe later on. Okay, you say?
Yes, sir. Yes, sir. Anybody have any query, please ask. I request participants, please, if you have any query, please ask.
Or even if they don't have, they can list down where. So should I start, or is there any
Yes, sir.
query? Okay. So next session, after becoming aware about the solar photovoltaics, that how to design such a system, that I'm going to share with you. Okay. So this case study is uh, 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 this you can so in which thing. Okay, this design.
Sir, hello, sir. Sir, your sound is breaking. Can you check? Sometime your sound is breaking and sometime it is smooth.
My system is working perfectly. Right now, can you hear?
Yes, yes. Right now is very good, smooth.
So all are
Uh, I re- I request participants, please give your feedback. Your
that
hello.
may be also,
All
that may be also
Actually,
because
sir,
of
I think you are using Bluetooth headphone. That's why it may be kind of the sound.
no.
breaking out actually. You can't even understand.
It's breaking now. It is breaking.
So switch off my all the participants are mute. That may be also causing problem. Uh,
No, sir. I
any-
think you'll have to stand still. You have to.
we yes. Okay, okay. Now am I audible?
Sir, you
Audible
audible,
or
sir.
intermittent? Okay, okay, okay.
No, sir, the voice
So
is clear
I-
now.
Okay, okay. So maybe because of that video or some other. Okay. So now,
Yes.
now see, I am going to give you some design steps for PV system. Okay. So what is the PV system? As we have discussed earlier, there are PV modules, combination of series parallel connected PV module. Then you have converter. So that converter has a responsibility to AC/DC conversion as well as maximum power point tracking. Okay. And your load may be DC or load may be AC or combination of both. Okay. And whenever you design a domestic load, okay, you need battery storage, right? So when you try to design any kind of this system, you always start with the reverse step. Okay, what is the reverse step? First, you collect the load data. First, you collect the load data, and then for catering your load, what is the battery requirement, what is the converter requirement, and then finally what is the PV module requirement. That is the step. Am I do you agree with me? Anyone?
Yes, sir.
Yes,
Yes,
sir.
Yes, sir.
it's okay now.
Okay. So whenever we try to design, we will first try to collect the load, then we will try to select the converter, then we will try to select the battery, and then finally the PV module. Okay. Now, remember, load may be the domestic load may be grid load may be industrial load. Okay. So here I have taken one example of domestic load. So PV module generate power during sunshine hours, daytime, and operation of the most of the loads they are required during off sunshine hours, that is nighttime. Okay. So that necessitates battery bank in standalone system, right? And PV modules charge the battery through MPPT controller during the daytime, and battery supply the load through AC/DC converter during night time, right? And now, is it okay? So, can you find out what is the load requirement, and for that, the design, and if and then connect one converter, connect more of batteries. Okay, first, right, what is whatever requirement? What is the words? So and point and converter system. Suppose uh, battery system, then battery voltage is 12 volt. Okay, it's designed consider the resistance single. So that
Excuse. Your voice is breaking, sir.
that be that be oh,
Sir, sir,
All
your
are
voice
having
is
the
clear. I think the problem is at participants end.
okay, huh? So problem is the participants. All the participants requested to keep their mic off, please. If on off and mic, okay. So I would start normally in the the for 77 because this 10 is that there of 12 okay you select you will see control to DC power to scientists so on bad how many bad and bad and you purchase many modules of this connected are considered for your PV system, right? So modules are rated power capacity, maximum power corresponding to maximum power. And let us go to some next slide. I have considered a load C lamp 9 watt and 5 hours is two number of lamps. Okay, fan 60 watt 8 hours one number. TV that is 152 hours. Reactor is
Excuse me, sir. Sir, can I hear you? Hear me?
I can.
Excuse me, sir. Sir, your voice is breaking, sir.
But
Hello, sir.
maybe connection problem. Okay, because others are listening me very clearly. Is that right? Others?
No, even in chat box,
Voice
it is.
No,
is
I am
breaking.
also not hearing clear.
Sound is breaking. Chat box message is there, sir. Please check your connection.
And, Paresh sir, am I not audible? Paresh sir?
Sir, your sound is very good, sir. I think it is a problem with participant side. Your sound at our end is very good, very smooth. I think it's
Because
problem with the participant
I
side. I think
have
uh,
switched off video.
and your sound is very good at our end, uh, but it is with the participants problem. I think they
Even
have to
the
mute the unmute them. Yes.
It is not the participant problem. Why them are complaining?
institute are they listening?
No, sir, your voice is breaking.
Then
So your
was
voice cracking in between. Sometimes it is very clear to hear, and sometimes it is like we can't hear anything.
Presentation is really very good, sir. It is very informative for us. But the problem is voice is breaking.
so switch off and should I start it again or I don't know why or what?
sit stand still. Whenever we are doing a presentation, we have to sit stand still. We should not move. That is when the voice breaks. We should not move.
So
Physically, we should not move, sir.
okay, I am sitting in the chair. Okay, I will.
Thank you, sir. Sorry for the
Okay,
sorry for the interruption, sir. But we had to tell it out.
okay,
Thank
okay,
you.
no. Okay. If you take any in which the basic code requirement in Peter, what done that is considered PV design. We consider the work or towards the or all the time, and is considered state area or in that is required our and our what first because to follow in
Sorry, sir. May I interrupt, sir? Sorry, sir. Panchal, sir.
yeah.
Sir, is your speakers are on of your system? Means
No,
if the speakers are on, the voice is echoing, sir. So it is echoing. Echo voice is there.
Okay,
Okay, sir. Then
no,
I don't know what it- okay.
Sir, can you use your system's microphones? I think it is a problem of your cord. Your cord is not connected properly. It is loose connected.
I have removed the cord, and is it now audible?
Yes, sir.
Yes,
Yes,
yes.
sir.
Now it is audible.
Yes, sir.
So now am I audible? I have removed
Yes.
my cord.
Yes, yes.
Very
yes,
clearly, sir. Go ahead.
It is very clear, sir, now.
Okay.
Yes, sir, you're
sir.
audible
Very
now.
clear.
Please continue.
Okay. So in this inverter selection, you must know what is the input voltage, what is the input current, and you must know what is the output output voltage. Okay. So normally in the DC in the inverter, the input is DC, and that is in multiple of battery voltage, 12 volt, 24, 48, 72 volt. Okay. And current may be ranging from 1 to 10 ampere, and output is always fixed, that is 220 volt, either 50 hertz or 60 hertz, right? And so now I have to okay, please excuse me for 1 second. I will close my door. So now the total power requirement from the AC side, that was 628 watt. Okay, it means continuously 628 watt I have to deliver through this inverter. Okay, of course you have to select the you have to consider the losses as well as, so you cannot consider you cannot take say 628 kV 628 VA inverter, but you have to go on higher side. Okay, even in market you don't get 628 VA inverter. Okay, you have to go on higher side. Why on higher side? Because you have to consider the losses, and you have to also consider the expansion of future load, right? So I will select, let us say, 1 kVA or 1.5 kVA inverter with with either of these voltage 12, 24, 48, 72, right? And so I have selected, let us say, 1 kVA inverter, and the input voltage is here 24 volts, because I'm selecting the system voltage 24 for this design, right? Of course, you are free to choose higher voltage also, because as you go for higher voltage, the current requirement will be reduced, and because of that, the cable size and all requirement losses, that will be also reduced. Okay, an inverter, they are on higher side efficiency 90 to 97%. Okay, so the average efficiency between these two, 90 to 97%, that I will select 93%. So my inverter is selected corresponding to 24 volt input side and 1 kVA. Okay, so what is the input energy required to the inverter? That is 2820 load requirement divided by efficiency of inverter 0.93. So whatever ampere requirement, whatever requirement, that is 3032.25. Okay, considering 93%. Okay, so what is the energy input from the inverter side? That is 3032.25 watt hour. Okay, now after selecting the battery, sorry, as I use system voltage, so right. So now 24 volt input I have selected, and based on that, I have also calculated the load, right? So now after the selection of the after the selection of the inverter, check the battery. So battery the ampere of this power based on chemical process. So what is the requirement? You cannot evacuate 100% power from the battery. You have to or with the battery. It evacuate up to 60% or give 30%. Okay, it means that 20% and 30% always there the battery, right? So battery is also different from this at 75%, 80, right? So my battery 20%. Okay, after what is the what is the output required? Now in volt, that is the 6.3 of FA. Now one per from the participant side. Am I right?
Yes, sir.
Okay. Now am I audible?
You are audible, sir.
Okay. Okay. So 3 year of Is that right? System voltage is 1.5 to batteries to cater this load. Yes. Any participant? How many batteries required? Yes. Otherwise, I am not. How many batteries? I disconnected.
2 batteries,
You are
sir.
connected, sir.
Okay. Okay.
Your voice is audible, sir.
Can I say 4 batteries? Two batteries. Let's see. To cater. So 4 batteries. Okay. I need total 4 my this load requirement. See. Okay. Sometimes what we is there is no sunshine. So when sunshine, then I'm unable to another 2 battery sets means 4 plus 4 total set. It is so is not all power that the normal battery pack is already utilize the other battery. Okay. The next day, again, one is not there. So I will select the third battery charge pair to deliver the. So this way I will employ more batteries. That is battery. So I will employ 2 extra batteries. Known as 2 and 3. Okay. Okay. Now battery. Okay. Okay. So here that and battery and left the left module. Module. I told you module they are available from 3 to 300. Even nowadays 500 watt is available in the market. Okay, so you have to based on that selected model you try to calculate the number of that was your load requirement, right? battery efficiency. Battery also takes some use. Okay. Battery also losing. Let me consider battery. Okay. Uh, which battery I also got right. So battery the wire from hour divided by 0.85 divided by 0.9. So 3963. Now we are 3 divided right. Now consider here has to take the model 75 watt and the voltage is 50 volt and current here that so 5 each module. So yearly these PV modules are required. It means that to get the 0.6 modules. So I need it parallel, but 24 volt. So I modules in. So two modules in are connected, right? So how much module is 27.5 ampere. Okay. Okay. So I have showed you the battery connection. I have also right. And now so connect any battery I hope you hear that participants, have you understood?
Yes, sir. Yes, sir. Yes, sir. Audible, sir,
Whenever I
audible.
don't get anything, I used to be Yes.
Yeah, yes, sir. Somewhat is breaking.
Now everything with system
Let it
only.
be, let it be, sir. You just continue.
Okay.
Just.
Error. Why participate? So I steps of this design. Consider the people and that design. Okay. That, there are two major considerations. PC system is clear, but not now. Today, let me tell you, if you want what is 25 rupees per watt, 20-30 rupees per kilowatt. Okay. Now, in Gujarat, the tariff of is 2.5 to 2.5 rupees. The, uh, of course, the local authority person officer of that then and then can in a case of the installation industries as so whenever I am going to install any system, I am always interested in the range of years. Well, and after those the PV electricity get included back is known as monthly is 2 years. From another interest that even electricity more with how see that is energy. So you may very much मैंने इतने पैसे invest uh, I will be also platform the participants cannot hear and organize.
All the participants are requested to please ask the questions if you have any query. The forum is now open.
I will share the PPT so you can.
Sir, suppose if you are using cascaded converters, then okay, what type of PV cells can we use, sir? Should it be module or should it be PV?
See, when you it is always This converter series and parallel. Okay, and which kind of module are available? Other modules are there, but they are not available.
Okay, sir. Thank you, sir.
Any more questions from participant side? Please.
Even listening.
Sir, I have one question. In comparison with the AC macrogrid, DC macrogrid, it is competitive.
DC. So this voltage variation problem and they can be they see when you have AC grid and you have or like energy sources. Okay, these are all DC-DC converter. They are required. Okay. These will come for DC grids. Okay. So from renewable, it is very interesting. And this microgrid offers access up to in AC. And sometimes only one conductor. Is that correct?
Yes, sir.
Faculty members, if you want to ask question.
Connect. Hello.
Yes.
Is there any question? One question. I think one question from our participant. They have given a chat box.
Yes.
Can we design on grid solar power plant for any rating?
What?
The question from our participant is from Rama Prasanna. Can we design on-grid solar power plant for any rating?
See, you can design. If you want to install the PV module, you design a power than expensive. Otherwise, if poor people are there, then not to consider the plain bill system available. Purchase complete purchase complete package. Okay. So design that depends depend the plenary space available.
Hello, sir.
Hello.
Yes.
Sir, I have one question. Actually, long back I have means I have gone through one seminar report. Maybe that is not very much studied on it, but that was beam power transmission. Means, the arrays are placed in the solar means near the sun, and the electricity maximum power. Do you think that will be feasible for us to get the maximum voltage or power from the sun?
As I told you, no, the bumper continuing phase loop. Converter job is to extract always maximum power. Okay, it will adjust the system voltage in such a way that maximum power level that is dumped towards the load or that is dumped toward the battery. Okay, so it is always feasible to extract maximum power using our converter. Now the other thing is that sun, right? Sun is moving from the panel. Uh, PV panel front surface. Water in all conditions.
Sir, I have one question.
Yes,
Hello.
speak out. Yes.
Sir, which MPPT technique is more preferable? Means whether incremental conductance or this fault of an observation method? Can you put some highlight on that particular aspect?
Okay. It may. Okay. In fact, myself have also developed algorithm other than incremental. Literally, it was my any sensing solar light is sensing not required because we okay. But okay, but still
Okay, sir. Thank you, sir.
okay. So now you can or even if so, Professor, I
Sir.
yes.
Sir, can you?
Thank you, sir. Thank you very much for this wonderful, knowledgeful session. We really thanks to you. And now within a few minutes only, we'll now go for a valedictory function. So all the participants are requested to please stay connected. Just within 2 minutes, we are starting our valedictory function.
Should I okay, okay. So I'll stop sharing and
Yes.
now am I
Yes, sir, you are visible. So it's time now for our valedictory function. A very good, warm, good afternoon to all. Once again, I am Olvani, Assistant Professor, ENTC Department, welcomes all the participants for this valedictory function of AICT sponsored online short-term training program on digitally controlled power converters for industrial and renewable application phase 3 under AQI scheme from 14 to 19 December 2020, organized by our Electronics and Telecom Engineering Department and Department of Electrical Engineering of SSBT College of Engineering and Technology, Bamburi, Jalgaon, Maharashtra. I also welcome our chief guest of today's function, Dr. Panchal sir. I also welcome Dr. K. Swani sir, Principal, SSBT's College of Engineering and Technology, Bamburi, Jalgaon. Welcome, sir. Dear friends, the main objective of the STTP is to update participants about the use of advanced power electronic systems in various applications. With this aim, the eminent resource persons from NITs, recognized institutes, and industries in the session has addressed key issues such as designing, modeling, implementation, analysis, and all about the power controllers for monitoring and protection of various applications for industrial use and renewable applications in this phase 1, phase 2, and phase 3. We know every event is an experience. The external fades away and the internal lingers and echoes in the most deep of our hearts. We are reminded that events like these one are milestone on the journey of our life. Hence, I request all the participants to give their online feedback. The participants, those who are interested, please give your feedback. Your feedback is very valuable to us. Few names are with us. First of all, I request Dr. Nandakishore Chauhan sir for their feedback.
Thank you, sir. Can I give oral feedback or I should write?
Sir, you can give oral feedback, sir.
Okay, okay, sir. Thank you. It was really an honor for me to attend this FDP in this pandemic situation. So I sincerely thanks the management, principal, coordinator, and the entire team of this engineering college, SSBT's College of Engineering, Jalgaon. Friends, I believe that the knowledge that have been shared by all the distinguished speakers will help immensely in the development of the students at my institute. So thank you very much for enriching our knowledge. I am not capable here to put my observations about the FDP in front of you all, but I can definitely share my feelings about this FDP as well. First, the topics selected for this FDP were really excellent. Second, all the speakers were really experts in their fields and presented their topics very brilliantly. Third, this is the most important aspect I can believe in, that is practical sessions in the afternoon. And I think this is the need of the fraternity, because mostly in my 28 years of the academic career, I have seen people are conducting very nice programs, but all so this FDP has given us quite good knowledge, practical knowledge, by conducting the practical sessions by the eminent personalities from the industry. Last but not the least, the entire team I found very enthusiastic and engaging. I really salute to their efforts. And last, I am really enlightened and definitely got the good knowledge from this FDP. And very important thing is I could learn something from my senior of my graduation, Dr. Paresh Shah. I'm very much thankful to you all, sir, for enriching my knowledge. Thank you. Thank you once again to everyone of this entire event. Thank you very much.
Thank you, sir, for your kind words. Now, I request our next participant, Mr. Mahesh Patil, for the valuable feedback. Mahesh, sir, can you listen
Okay,
me,
sir.
sir?
Okay, sir.
Thank you, sir. Thank you.
So to start with, I would like to thank principal of SSBT College of Engineering and the our Dr. PJ Shah sir and PV Thakur sir especially, because they are very actually innovative in kind of doing this kind of workshops and FDPs. Because we are in a small city, and in this small city we seldom get this kind of programs done. And if you can see that we are actually having speakers here from IITs and NITs, that is very rare, because you don't get actually the chance to listen to these kind of eminent people. But because of the efforts of Dr. PJ Shah sir, Thakre sir, we are actually able to listen them at our home, at our comfort places. So this is a very thing which I admire about sir. And then from 14th to 19th, we are actually got the knowledge which is particularly pinpointed towards the power electronics role in renewables, and it actually fulfilled my aim to actually join and this event, because if you see this from start day one, from Energy Swaraj, and the Dr. Chetan Singh sir actually told us about the sustainability. From that, then moving towards wind energy conversion system on second day, then on third day, digitally convert from photovoltaic system from Dr. PV Thakre sir. Also on next day, M.A. Mullah sir from SVNIT, excellent knowledge about development of BSCs and that base facts, right? And then Dr. PJ Shah sir actually gave the power electronic converters for photovoltaic system. So basically, all these topics are very important for us right now, because I am a research scholar and I am doing a PhD in my renewables. So these are the exactly the same topics which I have expected from the FDP, and they gave me very good knowledge about these things. And on the last day, as we have Panchal sir from SVNIT Surat, so he gave very nice information, solar cells and rooftop, you can say PV design of PV fundamentals, right? So with this, at the end of each day we had practical sessions. So this were actually fulfilling the gap of the theoretical and the practical implementation of all these things. So basically, overall, if you can see, it's a complete kind of package of FDP, you can see. And at the times of dynamics, we are getting this. So I am again very much thankful to the organizers, the team, from Vani sir to Dr. PJ Shah sir to Thakre sir, and nevertheless, and all this, the principal sir. So thank you very much, everyone. Thank you so much, and we expect more and more continuously from your side. Thank you.
Thank you, sir. One of our participant from overseas, Mr. Manikandan, has attended the complete session, but due to the today's exam, they are not available with us, but they have given their small video for the online feedback. I request PJ Shah sir to please play their feedback video. Audio, please. Sir, we are not getting audio, sir. Please connect to audio.
Vani sir, your voice is not coming.
Now audible? Okay.
Yes.
Okay, there is somewhat problem with the network, I think. So we will play the video afterwards. And now we are moving toward our next participant for the feedback. Anyone? Yugal sir,
Yes, sir.
can you present the feedback, sir?
Yes, sir.
Okay, please continue, sir.
So good afternoon, one and all present over here. I'm Yugal Kishore from NIT Raipur. So I'm very much unfortunate to have attend all the three phases of this particular short-term training program, which is organized by SBT. And I'm really thankful to the organizers and convener Dr. PJ Shah sir. And the content and overall STPP was very nice. And all the speakers are came from the eminent institute, and their course content was very nice. And definitely the whole STPP improved the overall knowledge of the participant. And actually I have attended many workshops during this pandemic, but I never attended such kind of program which having the such a good practical session, which improved a lot. Even though I have started working with the particular board which is explained by the National Infotech, and I found it very interesting. It is very interesting. So I congratulate all the organizers and maybe in the near future, if condition allows, then we will definitely come for the physical session if it happens in future. Thank you so much.
Thank you, sir. Your words will be really motivation for us. Yes, anyone? Dear participant, yes, anyone has to give the feedback. The forum is open. Your words will be really valuable for us. That will going to make us improve our next part and will motivate us for arranging such type of programs in our college.
Hello, sir.
Yes,
Oh.
sir.
So I am Tanmay Bhatt from Anand. So I am working as an assistant professor, College of Food Processing Technology and Bioenergy. So this FDP was really nice and it was really useful. Very practical issues like solar photovoltaic installation and very basics were covered, and this was very nicely useful. The explanation by Shah sir was also very useful, and this solar photovoltaics is really the need and demand for the hour, especially in the country where energy crisis is there. So it is very useful and it should be conducted again and again so that we know the different aspects of this. Thank you.
Thank you, sir. Anyone more? So, yes, anyone has to share the feedback?
Hello?
Yeah, Sham, sir.
So, good afternoon, sir. Good afternoon to everybody. So, I have experienced this workshop, this webinar as one of the very useful webinars I have ever attended. I have never missed any of these sessions, sir. Even after my classes, I usually come and attend this session because I liked it so much. It was very informative, and I was been watching all carefully. Once again, I thank all the coordinators for conducting this type of webinars. I will be attending all your future webinars if you send, sir. Thank you so much.
Thank you, sir. Thank you very much to all the participants. So, shall now we move toward our next part? Anyone more has to share your feedback? Okay, thank you. We are moving over to our next part. Now I invite Dr. Paresh Shah sir, convener of this STDP, for the welcome speech. Over to Shah sir.
Thank you, Mr. Amolwani. Good afternoon and welcome to all for the valedictory function. So, chief guest of valedictory function, Dr. A.K. Panchal sir from SVNIT Surat, Dr. K.S. Vani, principal of our college, Dr. Prashant Thakre, Mr. Amolwani and Mr. Nilesh Mahajan, all participants who have joined from the various parts of the country and all faculty members. As you know, Electronics and Telecommunication Engineering Department of and Electrical Engineering Department of SSBT College of Engineering and Technology, Jalgaon, Maharashtra have organized AICT sponsored online national level 3 short-term training program, and today we have completed all 3 programs successfully. Theme for phase 1 was power converters and controls. Theme for phase 2 was electrical drives and power quality issues. Theme for the phase 3 was renewable applications. In this STTP, we got eminent personalities from IITs, NITs, and eminent institute, and they delivered their valuable experiences with us. We got definitely benefit from these lectures. So we have tried with our best to make this program success, but you know, nobody is perfect. There may be some lacuna from our side. Please convey us so we can try to improve in future. We are always taking effort for organizing such activities. For this, we established MOU with eminent industries and universities for development of students and faculty members from last 5 years. We have signed MOU with Prince of Songkhla University, Thailand, with the National Infotech Surat, and with KVAT Solution Private Limited, IIT Mumbai. I would like to thank of National Infotech Surat for conducting all practical sessions nicely in all STTPs. My special thanks to Dr. M.A. Mullah, Mr. Viral, Mr. Junaid, and whole entire team of National Infotech for their kind effort and support. I am very much thankful to AICT for sanction the grant to conduct this STTPs, and my regards to Colonel B. Venkat, Director Faculty Development Cell, for guiding us time to time to organize online STTPs. I am very much grateful to organizing committee for their unlimited and unconditional effort to make this program success. My sincere thanks to Principal Sir, Vice Principal, HUD Electronics and Telecommunication, and HUD Electrical Engineering for their kind supports. Most importantly, I would like to thank all participants joining from all the parts of country. Their presence has made this program success. Thank you once again for joining us. Jai Hind. Thank you. Over to Amol Wani, sir.
Thank you, sir. Now I invite Dr. Ashish Panchal, sir, chief guest of today's function, to address the audience. Over to Panchal.
Okay, so am I audible?
Yes, sir. Yes, you're audible, sir.
Okay, okay. Now, since this SSVT college is a very old established institute, in fact, I have heard a lot of about this institute way back when I was in IIT. One of my colleagues studied in this SSVT. So since then, I was very excited to come over there and deliver lecture or meet people over there. But unfortunately, I got this opportunity to deliver lecture in SSBT Institute because whenever I think about Jalgaon, so the first name comes of this institute, that SSBT Institute. Okay, so today through this workshop organization, I got an opportunity to involve with this people of electronics and telecommunication and electrical department through Professor Paresh Shah and some other faculties. Okay, so I really thankful to this institute and the department for giving me opportunity to discuss the very hot topic of nowadays need of India, need of the world, that is on renewable energy, especially solar photovoltaics, and other topics are also covered on wind and solar. Okay, and as I also mentioned in my speech that without those solar and wind, all these are and other renewable energy sources are there, but without help of power electronics and power system and electrical and electronics engineers, these can't be fulfilled. Okay, this system can't be employed or can't be make into practice. Okay, so there is a lot of scope of jobs, there is a lot of scope of design jobs, and yeah, ITI level to IIT level, this system is required. Okay, ITI level to IIT level, this system is required. The engineers and diplomas and ITI candidates, and so that is why this is a very hot topic and conducted by this institute to inculcate these practices in young engineers. Okay, so only thing is that I'm not much excited that I couldn't come to institute physically and see the facilities and meet the people over there. Okay, though this situation has held us to meet on electronic meeting, e-meeting. So maybe in future I may visit the institute and I can meet the people physically and I can deliver talk over there. So with that, I again thank you, the principal sir who is available right now with us, and the other faculty members of the institute. And thank you very much.
Thank you, sir, for your influential message. We are charmed by your motivational words, and we invite you that whenever it is possible, please visit our college.
Yes,
We
yes,
will be lucky
definitely.
enough to have with you that time. Thank you,
Yes,
sir.
definitely, I will come.
Dear participants, nothing great will be achieved without great men. And men are only great if they are determined to do so. All such type of HTTPs, FDPs are possible in our college by the guidance of our principal, sir. So it gives me great pleasure to introduce our beloved principal, Dr. K. Svani, sir. Dr. Kishore Supanwani, Principal, SSBT's College of Engineering and Technology, Bamburi, Jalgaon. Sir has completed his PhD in biotechnology from North Maharashtra University, Jalgaon, M.Tech in Chemical Technology from Lakshminarayan Institute of Technology, Nagpur, and obtained DBM from Bharatiya Vidya Bhavan's Rajendra Prasad Institute of Management, Mumbai. He is an eminent academician with 33 years of rich experience and renowned administrator as principal of SSBT College from 2011. Worked previously as head of Chemical Engineering Department of SSBT and principal SMIT Polytechnic, Jalgaon. In his dynamic leadership, our college is NBA accredited 3 times, received ISO 9001 2008 certification, and presently NAC accredited. Dr. Vani sir is recognized PhD guide in Chemical Engineering and Technology of KBC, North Maharashtra University, Jalgaon, with many students completed their PhD and ME under their guidance. He also has been honored by various prestigious positions and chairs, such as elected Chairman Board of Studies, Chemical Engineering, Chemical Technology, and Biotechnology Engineering at KBC NMU Jalgaon. Member Academic Council, Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon. Invited member for Board of Examination of KBC NMU. Dean for Faculty of Engineering, Technology and Architecture. Member of BOS of Chemical Engineering and Technology. Member of 32/5 Committee, NME Jalgaon. Chairman for PhD Viva. Chairman LAC Recognition Committee. VC nominee on University Selection Committee. Chairman LIC Committee, and many more. In spite of the busy schedule, he has organized several workshops and events. Few are district level Avishkar 2050, Sanyojan Samiti Pramukh for Yuvarang 2015, Shiparas Samiti Pramukh, NMU Jalgaon Vice Chancellor Research Motivation Scheme. He is also awarded a letter of appreciation from MKCL on eve of Teachers' Day. Dear participants, Sir also has a patent on a method for production of orange-colored alphabetic pigment by Cyanobacterium intelligence. I think it is the first type of patent that Sir has received. Sir is having 50 plus research papers in various reputed international journals and conferences. He also serves as an active reviewer of many international journals and conferences. The fragrance of flowers spread only in the direction of the wind, but the goodness of a person spread in all directions. I invite Dr. K. Svani sir to address the gathering.
Thank you, Amal. Distinguished Chief Guest of today's function, Professor Panchal from SVNIT Surat, Professor Shekhawat, Vice Principal and Governing Body Member of our institute.
So your mic is muted, sir.
Head Department of VNTC,
Sir, you are requested to please start. I think it is somewhat problem of network or mic, maybe. Please, sir.
Okay. Distinguished chief guest of today's function, Professor Panchal from SVNIT Surat, Professor Shekhawat, Vice Principal and Governing Body Member of our institute, Professor Surarkar, Head of ENTC Department, Professor Pawar, Head of Electrical Department, Professor P.J. Shah, Convener of this FDP, distinguished speakers, staff members, and esteemed participants. A very good afternoon to everybody. I feel privileged to be here for this valedictory function of FDP on digitally controlled power converters for industrial and renewable applications. The FDP has been successfully conducted on virtual platform. I express my sincere gratitude to the eminent speakers for sharing their valuable time and expertise. I convey my best wishes to all the participants who would have certainly enjoyed this intellectual feast. I appreciate wholeheartedly the sincere efforts of all staff members who have left no stone unturned in culminating this FDP successful. Friends, this FDP has been sponsored by AICT. It was planned as a one-week FDP. However, the COVID-19 pandemic, which has changed the way we live in last few months, has influenced this FDP also. It has necessitated to shift the entire planning to virtual platform. It indirectly benefited a lot. We had in all 51 sessions, including 15 lab sessions in 3 phases, which would not have been possible on real platform. Around 20 eminent academicians have bestowed this FDP with their pearls of wisdom. In case of real platform, the number would have been certainly lesser. There were participants from 14 states across the country. Coverage of such a wide spectrum was possible due to digital platform only. It also manifests the digital strength of India, which facilitated us for this rapid transformation. Friends, learning is a never-ending process. Mankind cannot be an encyclopedia. Even encyclopedia needs amendments and updating. The FDPs keep us updated with latest developments in technology as well as all other aspects of knowledge. The 21st century is a knowledge-based century where the rate of creation of knowledge is tremendous. FDPs are required for academicians of all disciplines and all ages to keep them self-modernized and revived. The present FDP was on the theme of digitally controlled power converters for industrial and renewable applications. We are living in the digital era. Digital control provides higher accuracy, facilitates remote operations, and makes the records maintained systematically. I hope this FDP would have enriched the knowledge of all participants and they would have enjoyed it well. I convey my sincere thanks once again to eminent speakers, express good luck to all participants, and appreciation to staff members who have organized the event successfully. With this, I conclude. Thank you.
Thank you, sir, for your influential message. Your words were full of enthusiasm and valuable knowledge. Thank you, sir. So, with the kind permission of chair, now we'll proceed to our vote of thanks. Meanwhile, I want to give once again few instruction to participants. Dear participants, after this session, the evaluation test link will be shared on the chat box of this forum. to get the certificate, it is mandatory to attend the test and to fulfill minimum 80% attendance and 60% marks in test for getting the certificate. The certificate will be issued to your registered email from us within 3 to 4 working days. Meanwhile, all the participants are requested to please stay connected in a WhatsApp group. Further instructions will be shared in the WhatsApp group itself. And if you are having any problems, you can reach us through WhatsApp or you can call us. Thank you. So it's time for our vote of thanks. Dear participants and your valued invited guest, I deem it a great privilege to extend a vote of thanks on this occasion. First of all, I would like to thank our today's guest, Dr. Panchal sir, for gracing this function and their informative today's session. I would like to take the opportunity to express our hearty thanks to our eminent speaker, Dr. Chetan Singh Solanki sir, as a keynote speaker, Dr. Raghavan sir, Dr. P.V. Thackeray, Dr. M.A. Mullah, Dr. P.J. Shah, Mr. M.M. Ansari, and Dr. A.K. Panchal. Simultaneously, I will thankful to the entire team of National Infotech Surat for conducting practicals through all the sessions of eminent speakers, which has fulfilled all the objectives of HTTP and made a memorable one. We are also grateful for the AICT for their enormous support and funding for this HTTP. I also extend my thanks to our Managing Trustee, Sri Rausaheb Shekhawat, for their motivation and unstinted support for organizing this event. I wish to express my gratitude and thanks to our beloved principal, Dr. K. SVNIT sir, for their inspiration and guidance, which has made this HTTP successful. I am also thankful to our Vice Principal, Dr. S.P. Shekhawat sir, for their enormous support and guidance for the HTTP. I am also thankful to Dr. S.R. Surakar, HOD ENTC, and Mr. V.S. Pawar, HOD Electrical, for providing encouragement. I wish to express my gratitude to the convener of the HTTP, Dr. Paresh Shah sir, for their meticulous planning, execution, and efforts in organizing this event. A very hearty vote of thanks to all the dear participants for attending this HTTP. I think most of the participants have attended phase 1, phase 2, and phase 3. So we are very much thankful to them. I also express my sincere thanks to all the organizing committee members for their efforts beyond their comfort zone, which has made this HTTP successful. Thank you very much. I conclude the closing of this HTTP. Let me once again repeat my gratitude to all. Thank you.
I request all the participants to not to leave this meeting, because we are continuously posting the feedback and attendance link and assessment test link in a chat box only.
That link is showing error.
Now I can leave. Is that right, Paresh sir or Amol Vani sir?
Yes, sir. Yes, sir. Thank you, sir, for your presence.
Okay, thank you.
You may leave, sir.
Yeah.
Thank you, sir. say